Hello! In this video, we are going to be talking about solutions, acids, and bases, and we'll briefly talk about buffers. So, a solution is basically a mixture of a solvent and a solute. And when we're talking about mixtures, I want you to keep an example in mind. So, let's say our example is lemonade. And lemonade is made up of water, sugar, and lemon juice. The solvent is the component that is the most in quantity. So I'm going to say largest in quantity or amount. And the solute is going to be the least in quantity or amount. And the solute dissolves in the solvent. So I'm going to say here, solute dissolves in solvent. And remember, the solvent is the component that is the most in quantity. In the case of lemonade, water is then our solvent, and sugar and lemon juice is the solute, because we have water in the most quantity, and then sugar and lemon juice are in the least quantity, and sugar and lemon juice are what are dissolving in the solvent, which is water. You can think of any other example, like let's say coffee. You're making a cup of coffee. You're gonna have water and you're gonna have coffee beans. So think about which one is more in quantity, which one is less, and think about what is dissolving in what. So water is our solvent and coffee beans would be our solute. Acids and bases. So acids and bases are chemicals that have a certain formula. So acids will almost always have hydrogen in them, and bases will almost always have OH, hydroxide, in them. An example of an acid is HCl, which is hydrochloric acid, and an example of a base is NaOH, which is sodium hydroxide. The definition of acids is that when they are in solution, they dissociate, which means they break up, and they release hydrogen ions. So in solution, which means when they're dissolved in water, release hydrogen ions. And bases, when they are in solution, they release hydroxide ions. And so if you look at the hydrochloric acid, HCl, it will break up into H and Cl, and it's releasing this hydrogen ion. Sodium hydroxide will break up, will dissociate, and it releases these hydroxide ions. The more hydrogen ions that an acid releases, the more acidic it is. The more hydroxide ions a base releases, the more basic or alkaline it is. We have a pH scale, and the pH scale determines how acidic or how basic a substance is. So 14 is very basic, 7 is neutral, and 1 is very acidic. In terms of chemistry, something that is acidic will release a lot of hydrogen ions. Okay, this acid will release a lot of hydrogen ions, and a basic substance will release a lot of hydroxide ions. An example of a neutral substance is water, and water will release equal amounts of hydrogen and hydroxide ions. So water will dissociate and release equal hydrogen and hydroxide ions. Something that is very basic would be like a liquid drain cleaner, like Drano. Something that is around neutral, like I said, is water, and then our blood falls around neutral. It's around 7.2, 7.4. And then something that is acidic. So the most acidic substance would be something like battery acid. That would be around a 0 or a 1. And then lemon juice is also very acidic. So about 2, pH 2 is lemon juice. Let's move on to our last part, which is buffers. So a buffer simply is a substance, it's a chemical that prevents drastic changes in pH. So a substance that prevents drastic changes in pH. Okay, so let's say you have a water. Okay, we have water in this beaker here. It just so happens that orange juice is a very good buffer. So we add in a little bit of orange juice in here. I'm gonna say OJ. Now, if we put any acid into our water, the pH was originally 7, right? Water is 7. When we add acid, we expect that it will drop way down, right? However, if you have this orange juice buffer present, it may not fall down as drastically. So it depends how acidic your acid is. But let's say that it was supposed to fall down 3 points and go to pH 4. With the addition of that buffer, it might just go down, let's say, to 6.5, something like that. Similarly, let's say that you are adding a base. A base will make your pH increase. So you will go from 7 to, let's say, 11. Originally, let's say you were going to go from 7 to 11. However, because you have this orange juice present, it may go up maybe to, let's say, just 8.5, something like that. So buffers are very important in life. Our blood actually has buffers inside it. And so those will prevent drastic changes of pH and keep us alive.